exactly the same thing at the problem number 1. And we have exactly the same expression in here, fa and f prime of a, z minus a, z minus a, ez. Remember, we got that. Just the fact that f is not even analytic, is just a differentiable at a. And we got this condition. I corrected it here in my answer. E of a is 0. And you apply to not fz divided by z minus a, but z minus a squared. That's what I'm applying. Right? So you do the same thing. Slightly different distribution. First one didn't cancel. Earlier one in problem 1, this was just f of a divided by z minus a to the first power. Now it's the second power, right? This one, f prime of a divided by z minus a, there was z minus a with dividing by z minus a squared, so one survived, right? And another one survives right here. Okay, so let's look at this part, f of a divided by z minus a squared. 1 over z minus a squared. Is this, let me go ahead and take that and explain in the bottom there. Maybe this one first. There it is. Sorry, let's do that. Okay, 1 over the z minus a squared around, a in there, dz. It has a singularity. The Cauchy-Gaussat theorem does not apply. And you can directly parameterize it like that. But do you know any theorem that you can quickly calculate this integral around c? C contains a inside. Cauchy theorem does not apply because the singularity a is inside the region, right? Cauchy-Gaussat, reformulate the question but does not directly answer the question, right? What theorem applies it here? Cauchy integral formula is what we are actually proving. So because this is fundamental case of the Cauchy integral formula, so we're not. There's one more thing that in between these two we learned. What is the answer to this one? Anybody know the answer? How'd you come up with a 0? Its antiderivative does not have what? Branch cut. So that was a 0, right? So do you see that was the whole thing is a 0 now? Because fa is a constant, right? So that disappears. Not approaching 0. This is 0, right? How about the second guy? If you put the integral there, it has the antiderivative, does have a branch cut, right? So that will pick up 2 pi I right there, right? And f prime of a. Good. So that was supposed to be answered according to the Cauchy's integral formula, right? If you look at this guy with the squared, that's supposed to be 1 factorial up there, 1 derivative, first derivative. And that's a first derivative multiplied by 2 pi I, since I don't have here the 2 pi I in there. So that's, we got that, the second level of Cauchy integral formula. Make sense? All right. How about the last one? This upper bound and that analysis still survives. So this one turns out, again, is actually 0, but we show using the upper bound something MR. So that still survives. So I will leave that, this part of analysis for you to look at. It's the same thing. Okay? So using the same linear approximation, we could push that technique to G to the first level and Z to the second level.